In this video, we're going to be calculating molar mass for different formulas. In my previous video, we looked at counting atoms in a formula, and we look at the number to the right bottom corner right next to our element. So in this case, MgO, I don't have any subscripts in the bottom right corner right next to my elements, so it is assumed that I have one of each of these. So I would have magnesium, I only have one of them, and oxygen, I only have one oxygen because I have no subscripts. Now, when I'm calculating molar mass, it's the molar mass, it is the mass of all of the elements in my compound. So I have to look up the mass of magnesium on the periodic table, and I have to look up the mass of oxygen on the periodic table. So magnesium over here has a mass of 24.3050, and I'm looking at the mass number, not the 12, but the decimal that's on the periodic table. That's going to be for magnesium, so the 24.3050 if I'm using all of my digits. For oxygen, oxygen's over here. It says 15.9994. So I'm going to write that here, 15.9994. Well, 24 times 1 is 24. 15.99 times 1 is 15. So then, once I've multiplied them by the amount that I have, I just add them up together. 24.3050 plus 15.9994 gives me a molar mass of 40.3044 grams per mole. Now, something that might be confusing in class is that I haven't been using all of the digits on the periodic table. I've kind of rounded them, and it's been inconsistent how I've rounded them. So if you just want to be consistent and use all of the digits on the periodic table, keep it simple, then you don't have to remember which numbers to use, that's fine. If you wanted to round this, like 15.999, that's really close to 16. So I can just put in 16. 24.3, that's not ideal to round. If you round that one, then your number will be way off. It might not be incorrect, but it won't be as close as you want it to be. So 24.3, I would suggest keeping. 24.31 would be better. If you have 4 total digits, then you're good to go for your molar mass. But again, if you just want to keep everything off the periodic table, that would probably be best because then at least you're consistent. Let's try a couple more examples. So if I have Li2S, now I have a subscript 2, which means that I have 2 of the elements in front of it. So I have 2 lithiums. Lithium has a mass of 6.941. So 2 times my 6.941. My sulfur, well, I don't have any subscripts to the right corner of my sulfur, so it's assumed I have 1 sulfur. Sulfur, find it on the periodic table over here, element 16, has a mass of 32.065, and I just put a pen dot on there, my apologies. So 32.065. Now, I have this 2 times 6.941. Wouldn't be a bad thing to calculate that individually. So if I take 2, can't see that, 2 times 6.941, that gives me a total mass of lithium to be 13.882. My 1 times 32 is still going to be 32.065. Then I can add those 2 numbers up together, 13.882 plus 32.065 gives me a mass of 45.947. My unit is always going to be grams per mole. Let's get a little bit harder. So if I have CaOH2, Ca parenthesis OH2, recall in the previous video, that this 2 carries into the oxygen and into the hydrogen, and it's going to multiply in. So I have calcium here. There's just 1 calcium. The 2 does not carry all the way into the calcium. It's just 1 calcium. Calcium has a mass of 40.078. 40.078. Oxygen, I have 2 oxygens. Each oxygen, 15.9994. So I'm going to put that number here, 15.9994. And my hydrogen, I have 2 hydrogens, because that 2 carries into everything and multiplies into everything. Hydrogen has a mass of 1.00794. So I'm going to put that here, 1.00794. Before I plug this into my calculator, I'm going to find the mass of each of those. So 1 times 40, well, for calcium, that's just 40.078. That doesn't change, multiplying it by 1. For my oxygen, 15, let me put that here. I've got 15.9994 times 2 gives me 31. Let's see, I'm trying to figure out how you can see both of these. My apologies. Try that. We get 31.9988. Then for my hydrogen, I have 2 times 1.00794. So 2 times 1.00794 gives me 2.01588. Now, these are the masses of each of my individual elements. To get my total molar mass, I add them all together. So I'm going to take my 40.078 plus my 31.998 plus my 2.01588 equals, I get 74.09188. That's a lot of digits. I care that you have 3 digits in your answer. So let's keep the 7, 4, and then let's round this 0.9 to a 1. That would be fine for molar mass. Do grams per mole. Let's try one last example. I'm going to zoom out a little bit so you can see both my calculator and my work. My next example, let's try this one. It's a doozy. NH4, parenthesis 3, PO4. All right, this 3 carries into everything in the parentheses, and it's multiplied by everything in the parentheses. So 3 goes into the N, and 3 goes into the H. Multiplied. So N, I have, because of this 3, I have 3 nitrogens. Each nitrogen on the periodic table, 1.0067, excuse me, that's a 14. 14.0067. 14.0067. Then I have hydrogen. I have 4 hydrogens directly after I have a 4 directly after my hydrogen. I also have this 3 on the outside. So I'm going to take 4 times this 3. So that gives me a total of 12. Hydrogen on the periodic table, 1.00794. So 12 times 1.00794. Good. Then I also have a phosphorus. I don't have any number directly after my phosphorus, so it's assumed I have 1 phosphorus. This 4 is only for the oxygen, not the phosphorus. So I look for phosphorus, 30.973762. That's a lot of digits. Let's carry the first 4. So that would be a 30.97. And then when I look at my oxygen, I have this 4 on the outside, so I have 4 oxygens. Each oxygen is 15.9994, so 15.9994. Okay. Let's calculate each individual element. So I have 3 times my 14.0067. Let me change some settings here so you can see it. Is that a little better? For nitrogen, I have 42.0201. Then if I'm doing my hydrogen here, I've got 12 times 1.00794, which gives me 12.09528. Then I'm going to take my 1 times my 30. Well, I can do that in my head. 1 times 30.97 is going to be 30.97. And then this 4 times my 15.994. 4 times 15.9994 gives me 63.9976. That's each individual element. To get my molar mass, I need to add them all up together. So 42.0201 plus my 12.09528 plus 30.97 plus my 63.9976. I get an overall molar mass of 149.08. I could carry the 298 extra digits more than we need. I could round this to 3 or 4 digits to be 149.1. Again, keep in mind we've got our